Hey everyone, welcome back. My name is Eugene, and today we're going to be designing something that I have fancied for a very long time. So, I am a designer. I design products, and I am also in the field of technology from, I'm going to call it my 8 to 5. But I have a big passion for nature and things that we can get inspiration from in nature. And I really believe that really fun innovation and things that we haven't seen come out of areas that intersect between different verticals. And so, where I really find all that inspiration and passion from is the intersection of biology, design, and tech. Those areas where it overlaps, I suppose, has given birth to a lot of really great designs over the years. Not for me, just in general. And that's comes in a form of both simplistic designs and also complex things. Nature has a tendency of making things that are both complex and simple at the same time. So I am not saying that I know everything about that intersection, but I am learning and thrive to learn as much as I can about it. So today, we're going to take a look at an element of that. It's more on the technology side, but it pertains to a big passion of mine, and that is all things living. Love dogs, love pets, and I have a big passion from a long time ago. That is nature aquariums that are high-tech tanks. And I've done design work in this industry for a very long time, or had done for a long time. I don't do it anymore. But both aquarium industries, saltwater and freshwater, have done quite a lot of work in that space. Product design as well as sales work and product distribution work. All in my previous life, of course. But we're going to be making a light today for my personal tank at home. It is a high-tech tank. And for those that don't know what high-tech tank means, you can set up a tank whichever way you want, right? Take some water, put it into a bowl, add some rocks, add some fish, add some filters, and technically you're done. This tank is a little different. This tank is all about growing plants. It's all about automation. So dosing is automated, CO2 is automated, and then the lights are really bright. And they're bright for growing the plants, of course, but they're also bright for display purposes, showing off the colors of the fish if I have any. In this tank though, there's no fish. No, sorry, there's 2 fish. Everything else is shrimps. And yeah, I keep very niche things. And I find passion in them. I breed the shrimps, I have fun with the shrimps, I give the shrimps away to friends and family who want them. And they're at one point really expensive shrimps. I'm talking about like $30,000 shrimps, though they're not $30,000 anymore. And I'm just having fun in that hobby. It keeps me sane. It's like a zen moment when I'm working on the tank. But I need a new light. I threw together the lights that's on the tank right now. I threw together really quickly. A while back, I just CNC'd a chunk of wood. I threw some 3D printed legs on it. I threw some strip LEDs on that, and I called it a day. I want to upgrade that. I want to upgrade it for more light so that I get more growth in my plants. So I have better control over the growth, I suppose. And then I want to give the lights a flare. So the current lights are just white. I believe they're 6500 Kelvin. That's the temperature of the actual light itself. I'm gonna go with the WRGB setup. So it's gonna have white LEDs, but also independent channels for R, G, and B. So that's red, green, and blue. And then I'm gonna probably take the whole entire setup and put it onto a smart controller, so making the device an IoT device connected to my network and control it. I don't think I'm going to design the actual control system for it. I think it would defeat the purpose of this build to have full control like that. So what I'm probably going to do is look for a controller that allows me to control the 4 channels that I'm looking for. So that's the W, R, G, and B. And it should have an app synced up to it that I can just tap into. So I don't have to write the software. that will save me a significant amount of time. That will then probably allow me to focus more of this project on the actual industrial design of the product, the hardware, because I want this whole entire package to be self-repairable. You know, we're in a modern era of products that break that you have to throw away, and the only way to get a new one is to be able to, well, buy or repair significant amounts, and you have downtime. The thing with aquariums, at least high-tech aquariums, is downtime is a killer for this hobby. Algae is the biggest problem. Fish death if it's a filter problem. CO2, if you run out of that, is a big problem. Algae, again, kind of all revolves around that. So it's a very delicate balance to keep an ecosystem inside a closed container, which is an aquarium. And we need this thing to be up at all times. So self-repairability is a pretty big one for me here. So let's recap a little bit. We're going to make a light. This light's going to be LED centric. So we're not going to be using fluorescents or metal halides, even though I love the way that the shimmer happens with halides or single source lighting. But we're going to go with LEDs for that full control for the white W. So for the WRGB light control, so that's white, green, blue, and red channels. And then we're going to focus on self-repairability here. And then we're going to make this an IoT device on top of that. So I think without doing too much research, I need to figure out what is something I can get off the shelf that will be able to house all the LEDs. I'm thinking either a slab of aluminum that I can mill on a CNC into a heatsink. Got to figure out what the cost of that here locally is. And then I'm going to see if I can find a supplier that can sell me a heatsink and ship it here and see which one is more affordable. Once we figure that out, I think that's going to be the main thing. I can design everything else around it. So that's the fixture that holds the actual arms and legs and the type of LEDs that we're going to use. And then I'm going to source or find an LED controller that will do the job. Yeah, that sounds about right. Let's get to it. Okay, I have been on AliExpress, and this is by no means a sponsor or a shout out to AliExpress. I use them a lot for little things here and there, and I bought enough things to know that there is a significant amount of crap that I can't find on Amazon on here. And yeah, found a heatsink, 50 centimeters long. My tank is 60, so it's perfect for what I need it to be. I don't want it to be the full length of the actual tank. And it's $35 Canadian, landed at my door. I haven't even gotten to looking at what my local metal suppliers are gonna have on hand, but I doubt I would be able to get a slab of aluminum that is more than a 1/4 inch thick, so I should say 7-8 millimeters thick that I want it to be, 60 or 50 centimeters long, and then milled for $35. That's insane. Okay, so that's okay. I'm not even gonna explore that. I may just do it for fun and call around and see what the cost would be, and maybe throw that up on the screen of what I found out. But I'm gonna go with the $35 option here. This will work perfectly fine for the application. And then I'm gonna CAD everything up, throw it into 3D, and then start thinking about how I'm gonna make the framing for this light work. Yeah. What's actually also really good about this is the supplier has all the dimensions for the profile, the side profile for the heatsink. So it's 120 millimeters wide, it's 8 millimeters, 7 millimeters tall, and then all the dimensions for the fins are there, so I can actually make a super close and close representation of what it is in 3D before even getting this. So the design work can continue without me physically having it on hand. I just need to have the final thing to do final dimensional checks before I actually go and fabricate this, because there are going to be tolerance differences once the physical object gets here. So just always keep that in mind if you're going to do design work. Let's throw this onto CAD, and once it's there, I'll show you guys what we can do. Okay. This heatsink is actually really, really simple. It's 120 millimeters long by 7 millimeters tall. And I'm displaying this profile because I don't want to design this with all the heatsink cutouts on there. It is dimensioned, and that will be my next step anyways. So this is the basic profile for the heatsink. We're going to extrude that. The length of the actual material, which is 50 centimeters, 550 millimeters. No, sorry, 500 millimeters. And once we have that, we're going to design everything off of this face here. And that's going to be our profiles for the actual fins on this heatsink. That's fairly straightforward as well. The dimensions states that there is a dimension here of 8.5. So all the fins are 8.5 millimeters off of this edge. There is a spacing from the bottom edge here for 2 millimeters. And then the actual fin cutouts are 3 millimeters each, so the individual grooves are 3 millimeters wide. And from my calculation, there's 26 fins because the other side of the heatsink, it's also symmetrical, and it should also have a 8.5 millimeter spacing. Okay, so once we get that, we just extrude that all the way through. Yeah, there's no way I'm making this for $35 here in Canada. It's not gonna happen. Okay, that's pretty awesome. Yeah, there we go. So we have the heatsink here done. I quickly went in there and threw in this. And those are just supposed to be simple representations of maybe where I'm going to mount the screws or fix the screws to my fixturing. I haven't fully thought it through yet. It doesn't come with these holes. We may not end up using them. So I'm just going to leave them there for now. If we do use them, I think they're M3. I think, yeah, no, they're M3. They're 3 millimeters. Yeah, so they're supposed to be M3 holes. Okay. All right. Okay. So I've been going at this thing for now a couple hours. I drew some pictures and had an idea in my mind what I think I want this light to be. I spent the time taking measurements of my tank downstairs. It is a 60 centimeter tank. For those that are in the know, it is a original ADA 60p. So all those dimensions are fairly standard, straightforward. So this light that I'm designing will fit on any 60p or any standard 60 centimeter tank, which for any friends of mine that end up getting a tank in the future that want to build one, cool. Do plan on putting that out there as well. Let me just kind of go through some of my thinking for now so you guys can get a sense of what things are. Oh, give me a sec. You want to come in? Okay. That was my dog. He's under the table. Okay. Yeah, you know what? I'll grab some videos of him in a bit. Maybe now. You may see him on the screen, but that's all right. Okay, so let me share with you guys some of my thinking, at least some of my thoughts on how I was going to design this and probably which way I'm going to go now that I've thought this thing through. My original thought was to build a solid light that would be all fixed down to the heatsink as you build it. But the more that I designed and started to test out some of these thoughts, I realized that the heatsink is really, really thin. I mean, 7 millimeters is not a lot of meat to drill from the side profile in. And if I was to fix everything, I would have to build these blocks that go on the side. And those blocks are tiny, and I've got to stand them up. Inside a automated CNC, that should be perfectly fine, easy to do, and I've got access to one of those. But that 50 centimeter long heatsink standing on its edge, just have to do that manually. I'm not a big fan of doing that because it never is going to go straight. Yeah, there's just issues with that approach here. So I changed my approach altogether. This would have been an okay approach, but I came up with kind of the solution down here that you guys see. Okay, move this out of the way. So we're most likely not going to use those holes that I showed you guys earlier, the 3mm holes. They are still in the design, but we're probably not going to use them. So what I did here is a fairly straightforward kind of idea. The heatsink actually it's a floating element. It sits into this recess that is on the top of the channel that then sits on top of the tank. So if I ever want to service the light, simple, I can just take that off, and yeah, it comes off without me taking any screws off. This is really remnant of the original ADA, solar, I believe, light that they had launched, I think generation 1, but the heatsink in the light is just so much brighter. This, from my just simple calculations, is going to be about a 80-watt light, probably, if not a little bit more than 80 watts. Okay, just unsuppress that. So then the idea here is to machine this bar on the CNC, and there's a two-part operation actually. It's a fairly simple design. It's got two faces. It's got one face, that's where that's where the actual heatsink will sit into. So it's got a groove that's 7mm deep, and then we have another groove on the other side that will be for the splash guard. So acrylic, polycarbonate, PETG, doesn't matter. It's a fairly thin material, 2mm thick, with holes punched out that I can throw some 256 screws onto. This whole entire piece though is supposed to be machined in a single operation. The profiles are all designed for fairly straightforward operations, assuming that the CNC is large enough. There is then a manual tap that needs to happen from the side for a 3mm screw. And then these side arms just bolt on. Single-sided operation as well. Very simple design, all CNC out of aluminum, probably 6061 or something like that. Something easy to machine. And yeah, those should be quick jobs to do. Fairly simple and straightforward. My plan is to CNC them, test fit them. These side arms here will probably be 3D printed to make sure that the way that the light diffuses into the tank is even and it doesn't create hot spots. So that the legs have to be adjusted in terms of height. And I can only do that once the light itself is done, because I'm too lazy to do simulations. I could, but trial and error does the job here. Quick 3D prints to make adjustments. And then, okay, so CNC them. We're probably going to sandblast them. I'm going to try and find a local anodization shop that can do just a clear anodize on the aluminum pieces. And then we can start to put these pieces together. I'm pretty happy with the industrial design of this. It should work the way I intend it to, for it to work. Everything just slots in with fairly straightforward tolerances. So nothing is, 0.01 millimeters of tolerance. There's always a little bit of give and take in there. And that's just how it's gonna sit on the tank. This allows me to move it front and back when I'm doing work in the tank. Still, I can still have access to light when I'm working on it. And absolutely serviceable. Super serviceable, actually. Okay. I'm gonna leave the industrial design for a bit. Maybe I'll sleep on it. Maybe start working on what I think the light's gonna look like. And go from there. Yeah. Okay. Okay, so I've been sitting here just thinking about the type of LEDs that I'm gonna use for this build. And you guys have seen those common strip LEDs, the ones with the flexible PCB and then the individual dies that go on the top. I was originally gonna go with those. They do come in a WRGB version, but I decided against it. I want something bright. I want something with a lot of light that throws off a lot of light. And I've got these. These aren't really all that different. And the difference is they pack a significant amount more dyes under this silicone casing that's there, making the LEDs really, really bright. I love these. You don't need to use a lot, and they are water resistant on top of everything else. I'm probably gonna go with these. Yeah, most likely gonna go with these. So this is definitely not enough. Yeah, this is definitely not enough LEDs for what I need this build for. I think I need a total of like 5 feet, and I've got 1.5 feet of it. Let's go buy some, and then let's see if there you've got this variant in a WRGB version, and if they do, I think our job on the LED search is done. I thought about designing an actual PCB that I could then solder on Cree LEDs or any of the high power 1 or 3 watt LEDs. I could. Not a very difficult thing to do, but serviceability becomes an issue if the PCB broke under whatever circumstance. I would have to order another one. Same goes for these, but these are just so much easier. I just take the double-sided tape off the back, replace it, and go. I probably will be making a custom PCB for the junction parts though, so that I don't have a billion little wires hanging around all over the place. It's cleaner. I may have just desoldered 2 points, but that is going to be super simple. Yeah, I think this is the way I'm going to go. Let's make that PCB. Show you guys how to make that PCB. For any of those that already know how to design a PCB, this is nothing new, and chances are I'm doing it wrong because I'm not going to use any components. It's just going to be a PCB with traces. So PCB design. All right, I'm going to put the overlay on and show you guys. Okay, so there's a couple of important things to do before we get into the PCB design itself. The good thing is that when we designed the actual industrial design components, or the physical hardware components, we've laid out the actual hardware dimensions that we need to confine by. Otherwise, we can't actually make something that will fit into something else. So what's important is I've left this little space gap here in the design. And what we are going to do here is we're going to make a PCB that will fit between these two walls. So that's a pretty important dimension that we need to grab. And so what is that? We're looking at 112 millimeters. PCBs are then typically about 1.6 millimeters as a standard, if I remember correctly, 1.6 or 1.5. I can check, put it on the screen. And then what we need is for the PCB to fit under here, and then for the rest of the LEDs to go horizontally across. So I think that's it. We can make a guess about how thick the PCB needs to be, and then start getting this little piece of board made. Should be fairly straightforward. Okay, so we've got those dimensions, 112 millimeters, followed up by a PCB width that I can determine while I'm doing the work. I'm going to jump into Eagle. So SolidWorks is the software that I use for any of the CAD designs. I have used Fusion 360. It's fairly similar, and I do use it for any of the CAM work on the CNC side, but I'm more familiar with for just CAD and design work with SolidWorks. And Eagle, the PCB software, is something that I have worked with. Not the best at Eagle, but it gets the job done. I can't make any complex PCBs, but for simple PCBs like this, it should be pretty straightforward. I won't actually be jumping into how to lay things out in Eagle. There's a billion tutorials out there, but I will show you guys the little PCB that I have built, what it looks like, what its functions are going to be, and yeah, walk you through that. Okay, I'm going to switch the screen cap. Just give me a second. Okay, CAD is scary for some people, but the thing with CAD is it's an engineering tool, it's actually more about drawing and math to a certain degree than it is engineering. There is engineering behind it, but it's actually not that bad. It's all visual. SolidWorks is visual 3D. CAD, Eagle here is visual PCB layout. So you get to see all your dimensions and all your traces and how it all works out. Just the layout's a little different. So when I go from CAD to CAD software, and when I'm trying to pick up a new CAD software, I just keep that in the back of my mind, try and search out for the functions and the buttons I'm looking for, and everything else becomes a little easier. Okay, so we have our basic dimensions here then. 112 millimeters in terms of its width, and that goes between the two bars of the light. And then we have I'm going to go for a 19.5 millimeter width with a little piece of chunk sticking out from the side. And my plan is for that to stick out on the side of my light so that I can actually put a connector there. And the connector is just going to be a 5-pin DuPont connector, a 2.54 millimeter connector that I think I can get a 5-pin extension cable for. Super simple stuff. Just a design decision I made while I was making this PCB. So the thing about this PCB is I wanted to get rid of the clutter of the wires that would be there so that this PCB handles all that for me in a simple compact package. So all the white W channels are all connected. All the R channels are connected, all the G connected, all the B connected, and then there is a positive channel that carries all the positive channels, or all the positive connections to every single positive pad on the LED itself. The controllers will then switch on and off the channels that are labeled WRGB, and that should then turn on and off the lights and provide PWM. So that's my dimming if I need to for any of the channels that I have them connected to. This is how I'm going to connect and control each of the 4 independent channels, W, R, G, and B. And it's going to be very, very small. Very simple. Yeah. And then we've got 2 holes, one on the top, one on the bottom, for mounting it on the PCB itself, fixed so it doesn't move around, doesn't dangle around. And then all these blue pads that you see on the screen, that's for the actual connection to the LED strips themselves. The only thing that I did not decide on is whether or not I make this light an even number of RGB strips to the white strips, or go for more white, less RGB. I like to go for the more natural looks on my tanks, so most likely gonna go for more white. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 strips of LEDs that are going to be about 50 centimeters long, of which 3 of those are RGB controlled. Everything else is your standard white that I can turn the intensity up and down from 0% to 100. Yeah. Yeah. I mean, with all this, by the way, majority of the design is actually done. I think I'm gonna maybe do a bit of sleeping on the design and see if I like how it all is gonna come out. Once that is checked off, fabrication. Yeah, find a PCB fabrication house for this PCB because I'm not about to machine this out of a copper slab. A copper slab, or even ones with holes. You've seen those kind of PCB boards. I'm not gonna do that. I'm just gonna get it made. And then I gotta find a shop that can do the CNC work on the actual aluminum bar, the 60 centimeter aluminum bar that crosses the actual tank. That's a pretty big piece. I have a friend with a CNC that can do that. I don't. My CNC is a little smaller. Yeah. Once I do that, we will be back. The next time you see me, which will be a couple seconds later, I should have all the parts, or should have most of the parts, and we can start putting some of these things together. I'm gonna call it a day though. I've been working on this thing now for a couple of hours. I'm gonna give it a day or so just to think some of my design decisions through, and then if I'm okay with everything that I've made decision-wise, to fabrication, and I gotta wait for the heatsink to come, make the final adjustments based off that heatsink, and then LED controller finding time. Yeah, save you guys all that time, effort. Once I find one, we test it out. It should be good. See you guys in a bit. Okay, it's now been a couple of days. I've slept on this design and I love it. There is just something about the design that is about 90-95% of the way there that I can accept it for what it is. Is it perfect? No, but I think I can deal with that remainder 5%. So that means that I've gone and purchased every single component that I can buy without customizing it, like those aluminum arms that I need to CNC. But the LEDs are done, or bought, the heatsink is bought, the wireless controller, so I guess the LED controller, I found one that I think will work. We'll find out once it gets here. The power supply and stuff are all bought as well. But, as you can see, I've been editing this video and it's now 35 minutes long, and probably after this outro will be 40. So I'm gonna call this video done for today. It is very design centric, it's all about the process, and I hope it helps to show kind of what design looks like when a person or team is figuring out all the key decisions that need to be made. There isn't a lot of these videos on YouTube, so I'm going to try and continue to capture these. Do let me know if it's interesting. Of course, there's always the fabrication stuff that comes, the prototyping, the testing, the validation, all that stuff I can do once the components get here, but I can't. So I'm going to wait for all those parts to get here, make part 2 of this video, and keep going. For now though, I'm going to call this video done. So until next time, see ya. Bye. He just jumped onto the bed. What are you looking at? All right. Are you laying down or what?